Hi everybody, it's Mrs. Giesbrecht. Today we're going to be doing a Unit 2 test review to help prepare and make sure you guys know everything that you need to know before you take your Unit 2 test. So right now we are actually in week 7, so I'll be writing that on the next slide. So that's what Dropbox you will be using for today. So a couple quick things, make sure you have your notes organized, the notes that you're taking while reading your online lesson. I also highly recommend that you print out the transformations notes that I file transferred with you at the last session. And then always check and correct your checkup assignments with the answer keys and doc sharing. That way you can be doubly sure that you are doing things correctly and are understanding. Your practice worksheet is due this week. So as always, once you're done with your practice worksheet, you're going to email me and I will reply back with the answer key. It is worth 10 points extra credit. So your essential question for week 7, and I will put this up again at the end of the session, is to describe how you can determine the period of a function from an equation or from a graph. So I'd like to know both ways. When you see a graph, how do you know what the period is? When you see an equation, how do you know what the period is? So here's a couple fun facts to remember. We did go over these last week, but they are crucial to point out again. So only trig functions are considered to be sinusoidal. Hint, hint, you might have a question like that on the test. Only your sine and cosine functions have a domain of all real numbers. Everything else has some type of restriction. So whether it be an asymptote, well, they are asymptotes. And then your even functions are symmetric around the y-axis. And some examples of sinusoidal scenarios would be hands rotating around a clock, a CD player spinning, or a pendulum swinging back and forth. So anything that has some kind of a constant wave-like motion. So we're going to jump right in today with the period and how quickly it repeats. I'm going to go ahead and file transfer to you this PowerPoint. That way you can have it if you would like to print it out. So let me grab that for you, 1 second. Okay, so it's coming your way. When it comes through, go ahead and save it. And if you would like to pause the recording and print this out so you can write right on top of it, that would probably be an excellent thing to do. Okay, so if I ask you which function's graph has a period of 2, let's remember and remind ourselves that period is how quickly a graph repeats itself or how often it repeats itself. And the way that we find period is we take the regular period for the function and we're going to divide it by the b value. Now just a reminder of where your b value comes from. We covered this at last week's session. If here's our formula, our b value is always the one right in front of the x. So let's highlight where those numbers are in my 4 examples here. So that would be the 3, the 2, the pi, and in front of this x is actually just a 1, just out in front there. So what I need to do to figure out which one has a period of 2 is I need to take the regular period and divide by b. So for sine and cosine functions, we learned last week that they have a period of 2 pi for their regular period. So this would be 2 pi divided by 3. This one would be 2 pi divided by 2, 2 pi divided by pi, and 2 pi divided by 1. So by the time I reduce here, the top one's going to remain 2 pi over 3. This one would be pi, this one would be 2, and this one would be 2 pi. So the one that has a period of 2 is this second one right here. So just practice that, finding your b value, highlighting it, and then using this formula. For understanding domain and range, let's think for a second about this question. It says, at which value will the graph of y equals cosecant x have a 0? So as we're thinking about cosecant, we need to really remember what cosecant is. Cosecant is 1 over sine. So I pulled up the unit circle here because I want us to remember that 1 over sine is the same as 1 over opposite over hypotenuse, which is really the same as hypotenuse over opposite. So when I'm looking at my unit circle, where would I get a value of 0? which one would give me a hypotenuse divided by opposite equals 0? Well, in order to get a 0, we would need a 0 in the numerator. Everybody okay with that? Because if my denominator was 0, that would be undefined. So the only way I'm going to get a 0 as my answer is if my hypotenuse is 0. Well, by looking at my unit circle, I'm never going to have my 0 in the numerator. My hypotenuse is never 0. Because on a unit circle, what is my hypotenuse always? My hypotenuse is always a 1. So, none of the above are correct. Plus, if you think about it, let's find pi over 2. Pi over 2, if I did hypotenuse over opposite, so that would be 1 over, well, there's not really an opposite, so that's undefined. If I did pi over 4 right here, hypotenuse would be 1 and opposite would be root 2 over 2, so that's not a 0. If I did pi thirds is right here, hypotenuse is 1 and opposite would be 1/2, so 1 over 1/2, so again not 0. So none of the above are correct. So when they're asking you where do these have certain values, just pull back up your unit circle and have it handy so you're reminding yourself what exactly it is that they're talking about, or you could also graph that. When you graph it, if your graphing calculator does not have a cosecant button, this is how you would type it in, because it's 1 over cosine x. And then your graph would work, and it would graph just fine. So last week we talked about transformations, and I just want to touch on it briefly before we move forward. So if here is my basic function, we learned how the a, the b, the c, and the d all transform my function. So b, we know that that's directly related to the period. And what we're going to talk about later in today's session is how c affects it. C is also called the phase shift. Hint, hint, that's a key phrase that is going to show up on your test. So C is a phase shift. The phase shift is always inside the parentheses and it's not attached to the x. So it's always your other number inside the parentheses. So phase shift. Which of the following functions illustrates a phase shift? So again, we just have to understand where it's at in our formula. So if I have a sine bx minus c plus d, and we said c is our phase shift, which one of these has a c value? Which one of these four has a number inside the parentheses, not connected to the x, but inside the parentheses? That would be d down here. The phase shift would be the minus pi. And again, if it says minus pi, that's really going to be a positive, right, when we pull it out, just throwing that out there. Remember, when it's in parentheses, we always do the opposite when it comes to the graph. So you will have a question just like this on your test. So let's work backwards for a moment. This question gives you the graph and it asks you which one of those is a possible option for your function. So here's the first thing that I look at. The period is usually very, very telling. So if I look at the period of this function, it goes from here to here. So this one has a period of 2 pi. Automatically, that's going to eliminate some of my options over there, so let's check them out together. Remember, the way that I find period is we take the original period and divide by b. Where do we find b? B is the number right in front of the x. So here's b, right in front of the x, here's b, here's b. So if I need to have a period of 2 pi, these are all tangent, cosine, sine, cosine. So we know sine and cosine should have periods of 2 pi. So the original period, 2 pi divided by 4. This one would have 2 pi divided by 1, 2 pi divided by 1. So we automatically know that this one can be ruled out because this period would have a pi over 2 period. Now I'm going to go further and say that it's either going to be C or D. So think for a second, how come I can rule out tangent? How come I can rule out a tangent? Because this function, this type of a shaped function, is always a sine or a cosine function. Those two are your sinusoidal repeating graphs that look like this. So we can go ahead and cross off tangent. Okay, so now we have to ask ourselves which one of these two could it possibly be. So let's take a peek at sine. Sine is telling us that this pi is going to shift left pi spaces. So let's think about if this graph does that. And then down here on the bottom, this one, think about what this -2 is really saying. That -2, I really have negative cosine x minus pi. And if I stick that -2 down here at the end, do we remember how this -2 is what it's going to do to my graph? It's going to shift my graph down 2 spaces. Is this graph down 2 spaces? It's not. So I can automatically cross off D. So that leaves me with this answer right here. If you are unsure, you can always graph all 4 of them and check them out. But I want you to know that I didn't have to graph any of them to find the correct answer. I could use the period. I could use that it crossed at 0, 0. I could use all kinds of key information. So let's try that again on the next example. So here's another one for working backwards. Okay, so let's start again with the period. Period goes from here to here, so up and down. So this has a period of 2 pi again. So I can ask myself which one of these do not have a period of 2 pi. So here in front is a 4, in front of here is a 1, in front of here is a 1. So we said earlier it's the original period divided by b. So that's going to give me a 1/2 pi, so that doesn't work. The cosine's fine. Now tangent and cosecant sometimes have, you'll need to double check their period and what their original period is in order to use this equation. But the telling part of this graph is really where the center of the graph lies. So for instance, we can tell that this graph has definitely been shifted down, right? Because more of it is below our x-axis than is above the x-axis. So if I try and find the central middle line, that would be down 1, 2, 3. Right here at -2, it goes straight through the middle of the graph. Here's how I can be doubly sure that I picked the right spot. Check it out. I have 1, 2, 3 spaces above and 1, 2, 3 spaces below. That's how I know I did it correctly. Only one of those graphs over there shows a shift downwards of -2. Can you guys pick out which one it is? Which one shows a downward shift of -2? There you go. So there are lots and lots of ways that you guys can pick out the correct graph. I would always start by doing the period, and then secondly, you can look for any shifts up or down. Those are the most telling ways to, for me, it's not the only way, those are just the #1 ways that I use to tell which graph is correct or incorrect. And again, you could always graph them as well. Like cosecant has all these weird asymptotes to it, so we knew it wasn't cosecant. And tangent or something like that. So anyway, you should sort of have an idea of what the main parent function graph looks like. So what a tan x looks like, a cosine, a sine, a cosecant. So somewhere in your notes, maybe just graph those quickly on a graphing calculator so that you have those little sketches done for you. But again, #1, try the period, check the period. #2, check for any shifts up or down, because again, that's the most telling features of the graph. So when it comes to understanding range, remember that range are your y values. So when I'm looking at these graphs and I'm looking at the range that it's telling me, this is saying that it's going to go from -infinity to 2, and it's going to include 2. Then there's going to be a break in my graph. My graph is going to pick back up at 0 and continue to positive infinity. So I need to know which one of these 4 graphs is going to have a break in the middle between -2 and 0. Well, just looking at the 4 of these, I know that my cosine graph goes up and down. that's definitely not going to have a break in the graph. So I can kind of cross that one off from the get-go. Now, cotangent is the same as 1 over tangent. Secant is the same as 1 over cosine. And cosecant is the same as 1 over sine. So again, somewhere in your notes, I would love for you to have quick sketches of what each of these look like with their parent functions. So cotangent always kind of goes like this. Secant and cosecant are going to be like this. So that's going to cross off tangent for us because all of these little S waves are going to go all the way up and down. You're never going to have a break through the middle of the graph. So the two that I would like for you guys to explore on your own using a graphing calculator to try is 1 over sine minus 1 and 1 over cosine plus 1. The key is plugging it into your calculator correctly. So let's talk real fast about what you would want to do. You would want to have the 1 over sine x in parentheses and then the minus 1 outside the parentheses. Because otherwise, if you don't include the parentheses, it's thinking this. Sine x minus 1. And that's a difference. That's a different kind of a problem. So the calculator does not read our mind. Things that we want to stay together, we need to put together using parentheses. And I want you to try out the top and the bottom. Go ahead and press pause, and when you are ready, you can press resume to find the correct answer. And the correct answer is the top one. Cosecant x minus 1. This bottom one down here, the y equals secant x, it actually touches at 0. So that one doesn't work. Okay, scratch that. They both actually touch at 0, both of these. That's not why the bottom one doesn't work. The bottom one is actually from, if I have this right here, it goes from 0 up to 2. 0 up to 2. So that's not the range that I'm looking for. It's the top one that actually works. So they both touched at 0, so that was incorrect. Plus it can touch at 0 since it is included in the original. So just graph both of them and you would be able to see which one has the correct range. So I hope that this was helpful in preparing for your test. So again, here's our essential question that you will put in the Dropbox for week 7. It says to describe how you can determine the period of a function. I want to know how you determine period from an equation and how you determine it from a graph. Thanks guys, have a great day, and I think you will do amazing on your Unit 2 test. Just be sure to email me once the practice is in the Dropbox. Thanks.